Okay, awesome. Hello, everybody. Thanks for joining again for the third webinar of this Concordium series. Today we're joined by Dragos again and Doris, who are going to be looking at the verifying access with Concordium ID. If you guys want to get the chat going and drop in where you guys are from, and let us know how you guys are finding this series so far, that'd be great. And as always, if you have any questions, chuck them in the chat. The team will be constantly eyeing them, so can get back to you throughout. And then we might have time at the end for a Q&A session if we have lots and lots of questions as well. But yeah, for now, I think that's all I've got to let you guys know. And Dragos is going to kick off, and then Doris will take over for the second half. And yeah, enjoy. All right, Doris.
All right.
Listen.
So, welcome to the third installment of the Concordium Educate series. So, in the past two times, we've talked about the identity layer and an overview. Now, today is going to be a synthesis of all of that and how it's actually applied in the market and how you can actually build an app using that. So, we're going to be talking about verifying access. Now, we'll mention again a bit more on the problem with traditional identity verification. Then we'll showcase the verifying access solution that Concordium provides. We'll talk about the verification flow with the user setup or provider setup. We'll talk about the verification anchors. So those are something quite interesting that you can do with zero-knowledge proofs. We'll get around to that later. Talking about choosing a verification method, so ID versus account. We've said before that initially you will get a Concordium ID, but then you can create an account from that. Selecting an identity provider. Then we're going to go through the technical architecture of actually building an app and what you're going to be using. We'll look at building proof requests. At the end, we'll talk a little bit about managing transaction costs. And at the end, my colleague Doris will be doing a live walkthrough of an app. Now, we've mentioned this before, the problem with traditional identity verification. So at the moment, last year in 2025, the average cost of a data breach was around $10 million in the US and around 4.4 globally. Now, this, along with the compliance burden growing significantly with every new regulation. So we've had MiCA in the past couple of years, for example, GDPR, Age Verification Acts, and a bunch of others, means that every piece of personal data that's collected becomes a target. On the other hand, currently traditional ID verification is quite expensive. So Stripe, if you want to use that in your app, for example, Stripe charges $1.50 a check, Samsung $135, and then enterprise contracts will start at around $50,000. Now, the problem is, after paying all of that, you still have to store all of the personal identifiable information. So you're still open to the risk. What this means for users is that at the moment, there is oversharing. So if you go out to a bar and the bartender asks for your ID, he's not going to need your passport numbers, right? And you also have no control over how data is stored, shared, or sold. And there's also repeated onboarding across every service. So you're going to one app, you're going to have to go to the entire process, and then you switch to another and you have to start over again. The tension here is that regulators demand verifiable checks, but users demand privacy. Both are right. I mean, we do need to have regulated applications, but at the same time, everyone values their privacy. Now, Concordium's answers. So verifying access, this is done through zero-knowledge proofs. So zero-knowledge proof, we mentioned before, is it proves that the statement is true without revealing anything beyond that statement. So you can easily say I am over 18 and that's it. You're not going to show your age. You're not going to be doing anything else. Now, verifying access provides the user the ability to prove their attributes from their Concordium ID using zero-knowledge proofs. Then the merchant will be able to verify the proof without seeing any raw personal data. Every check will be anchored on chain for an immutable audit trail. Now that's quite important because at the end, what we all want, if after 2 years of somebody visiting your website, which is restricted, let's say, an auditor comes and asks you, well, who was that person or why did that happen? You should have something that's immutable, that's never going to change. So the blockchain is used for that. But at the same time, there is no personal identifiable information stored on chain. For second finality, as we've mentioned before, and it's going to be 2 cents per anchor this time. So I've mentioned before that it's 1 cent per transaction in Concordium, but anchors are a special kind of transaction. And at the end, for the user, it will still be 1 tap and no document re-uploads. You will be able to use your same ID everywhere. Now we have a 3-party model going on here. So on the left side, we have the user. The user just wants to prove that they're over 18. Then the merchant will need to gather that proof, but without collecting any data about the user. And then the chain will be used to actually have an audit anchor. So basically what's going to happen is that the user is going to prove via zero knowledge proof. The merchant will verify without actually storing any data. And then the blockchain will record an audit trail from start to end until that interaction has finished. Now let's talk a bit about the one-time setup. So we have on the one side the user. Before the user can verify, this is what we went through before with creating an account. So you need to download the Concordium ID compatible app. So here you will have the Concordium wallet on iOS, Android, or web. The standalone Concordium ID app, that's if you only need the ID, no account associated, or Coin98 and Ledger. Then you will onboard with an identity provider. The identity provider will validate everything and then issue you a cryptographic identity credential. And at the end, if you are using a wallet, you will be able to create an on-chain account. Now, that's all that the user has to do. After this is done, a user can verify on any platform that integrates Verify and Access. On the other hand, as a service provider, so you're building an application, right? You're offering a service, a product to anyone. All you need to do is to connect to the chain. So you will either run your own node or use a hosted node service. Then you will have to deploy the verifier service. We offer an open source Docker container. It's going to be hosted in your virtual cloud. This handles all of the zero knowledge proof validation and on-chain anchoring. And this will be, proof data will never leave your actual infrastructure, so it will only stay there. Then you will need to integrate Wallet Connect or Reown. And you will need to register on Wallet Connect Cloud for a project ID. This can be done quite quickly. And it will enable QR code pairing and deep links. At the end, you will just need to update your UI and display the verification prompts, gather results, and all of that. Now, let's talk a bit about the integration architecture. So on the left side, we have what a user experiences. This should be quite seamless from a user's point of view. So you will, if you're on a web, you will just scan a QR code. If you're on mobile, you will just tap on a deep link. You will get a request in the wallet or ID app, and then you can approve it. Afterwards, access is granted, that's it. But in the background, a few things happen. So first of all, let's go top down and talk a bit about the integration architecture. So this will be your infrastructure. You can have a backend API. So this is based on the actual demo that we'll showcase, and there's the tutorial with that. So here we have Next.js API routes. Just 2 simple ones, create a proof and verify a proof. You will have a database for audits because one of the anchors, the verification audit record, this one will actually have to be stored off-chain. So this is a private compliance log that you can store and then show anyone at any point. Then this will, your API will make a call to the verifier service. This has a private key that is read-only because it will actually deploy transactions on chain. Now, once you go out, this will all communicate with the blockchain through a Concordium node. And then on the chain, you will have 2 more anchors, which are going to be the verification request anchor. This is on chain, and this is logged before sending the request. So the moment a user enters your website and starts the verification process, this will be logged. We will explain all of the anchors in detail. And at the end, you will have a verification audit anchor. This is also on chain, and this closes the audit trail. Now, behind the scenes, this might seem a little bit complicated at first. It's just a design architecture for what happens in the background once those requests are made. But this all happens seamlessly by using the verification API. So in the browser, a user will click on verify age. A post request will be created that will go through to your API. Then your API will create a request to the Concordium verifier. In this moment, the first anchor, the verification request, will be actually put on chain, so a transaction will happen. This is in order to avoid replay attacks, for example. So you can say that at this exact second, when the user started, this is the actual time and this is the user. Then you will get the verifier will send back a verifiable presentation request. So we've talked about verifiable presentations in the previous workshop. This is basically just what goes into the wallet in order to ask for a zero knowledge proof, along with an audit record ID. The session ID and the request will go to the browser. Then through your client, your application, you will be able to show a QR code. Afterwards, the user will scan it. A wallet connect session will start. So you're using the mobile wallet in this case. And the verifiable presentation will be sent to the wallet. Now, the verify steps. So at this point, we're in the wallet itself. The user will be able to approve or deny the request. If the user denies, it will all stop here. If the user approves, though, then a zero knowledge proof will be generated. This will all go back to the client. And then the client will do a call to the verify endpoint in your API. Now you will send all that to the verifier. The verifier will validate everything, and then you will be able to have a verification audit record. This is stored on chain. So you will be able to store this in your database. This isn't any proof about the user. This is just some metadata and something that actually links to what is on chain. And at the end, when this was all completed, you will be able to store a final anchor, a verification audit anchor. What this says is basically that the user has verified everything. As you can see, the transaction hash will go back, the client will get a success pop-up, and the access will be granted. So once we've gotten to this point, you will be able to have an immutable audit trail that somebody has sent. I'm seeing a message in the chat. So the wallet is not the same. It is not the same as the browser. In this case, the wallet will be a mobile wallet. You could have a web wallet, of course, but in this scenario, it's just a mobile wallet. The browser represents the client here, so the client that is consuming your API. Now, let's talk about the anchors in depth. So we have the first one, which will be the verification request anchor, VRA. This is an on-chain transaction that's initiated by the merchant or service provider immediately after generating a presentation request, but before actually sending it to the user's ID app. So once the user starts the process and they consent that they want to verify their age, for example, this will be put on chain. The goal of this is to allow the ID app to confirm that the presentation request is both authentic and recent. So it will create an immutable, publicly auditable, time-stamped record that the verification process has begun. Now, what's quite important about that is that it's going to be time-stamped. So that means that it will prevent replay attacks. If you've got an attacker listening to the channel, they won't be able to use the same process and to pose as the user, because the wallet will check that the anchor exists and is fresh before actually generating a proof. So if you have somebody attempting a replay attack and they will try to actually pose as the user, the wallet will just deny the proof instantly because they can check what's actually on chain. The key details here is that this is going to be written on the chain as a transaction. There will be a small transaction fee, so around 2 cents compared to the traditional ID verification method. This is quite small, I would say. It contains no identifiable information about the person. So this is only proof that a request was made at a specific time. And this must go on chain before the request actually reaches the user's wallet. So before a user will actually use your your app, this will have to be on chain and the wallet will check for it. Now, the next one that will be generated, we've gotten to the point where you can actually store something in your database. So this will be the verification audit record. It's a private record that is stored by the merchant off-chain as a result of verifying a presentation. This will be shown to an auditor as needed if it's ever needed. The purpose of this is so that a merchant can have an internal proof that the verification check took place. So not only what's on the chain, but this is related to what's stored on the chain. It will only have basically the metadata of the session, so no raw data. And this is the primary document used during regulatory audits. So if you're offering a service and want to use Concordium for identity verification, you won't have to actually go to the chain every time to prove. You will just be able to send this to any auditor, and it will be enough because this will be linked to what's actually on chain. This, of course, must be encrypted with strict access controls. There should be daily backups and multi-region replication in order to be fully compliant and to be able to serve any region. If this is lost, the merchant will lose the ability to provide the validity of a verification request, even if the on-chain anchors exist. Because if you don't have this, you can't prove that it's actually your website that put those on-chain, and you can't create a link between them. Now, the final anchor will be the verification audit anchor. This happens at the end. So it's an on-chain transaction that will be written after a verification is completed, and it will fully close the end-to-end audit trail. So after this point, you can say that you've actually proven that the user was over 18, for example. The purpose of this is to prove that the verification was successfully resolved. So from that moment on, the user can be granted access. There will be an immutable record created, and it will enable a third-party audit. The way this works, an auditor can come in and just ask for the initial verification anchor. They can hash it and compare it to the on-chain verification audit anchor. So if they match, the record will be proven authentic and unmodified. This will also be written as a transaction. So it's the second one. We're only doing two transactions for this entire process. The transaction fee will stay the same. And together with the verification request anchor, it will form a complete on-chain audit trail. So a request will be initiated, an audit will be put on chain, and then at the end, another one will be placed on chain. Again, no identifiable information will ever be included in the anchor. Now let's look at the full chain. So we have the initial anchor. Then we'll go to the one that's actually stored in your database. This one isn't going on chain, and then the audit anchor. And these are 3 records with 3 separate purposes. So the blockchain itself will be a digital notary, fully immutable. The data there is never going to change. No identifiable information is written. And if an auditor wants to actually check that the user was over 18, they won't have to actually look at the user's data. They will just be able to follow the initial request that was put on chain as a transaction. Then as a merchant, you will have to provide the anchor that is in your database. And then at the end, they will be able to check the final audit anchor that is stored on chain. And this will prove that integrity was confirmed. Now, the total on-chain cost will be around 4 cents. So again, this is much smaller than all of the other solutions that we've discussed. And this is in depth. So we have the verification request anchor. This is going to be on chain. This says that at a specific time, a user has been requested to verify, proves that the request is authentic and recent. Then we have one which is stored off chain. This is going to be the verification audit record in the merchant's database. This means that the verification took place, and here is the result. Basically, it's all that you have to store. And it's a private compliance record. You don't have to make this public, only if needed. And at the end, you will have a verification audit anchor. This will also be on chain, and this proves that the verification was completed and is going to be fully tamper-proof. All right. Now let's talk a bit about choosing a verification method. So we have two methods here, which will have the same technical integration. So if you're building an app, you will just be able to choose between these two. It will be the same verifier server that's going to be used, the same wallet connect session, and the same proof request structure, so nothing will change there. The only difference here will be what the user proves. So we have a simple diagram here. Does the user need to make a payment? If the user needs to make a payment, then you will need to go against an account. The user will need the full wallet, and you will have both payments and identity done both through Concordium at the same time. If the user doesn't need to make a payment and just needs to access your content, for example, this will be done against an ID. So the user won't need an account. They can only use the ID app, for example. And this, for example, is quite useful for people that, let's say, aren't that used to blockchain, but they will still be able to create an ID, and the chain will still be used to actually have an immutable proof of everything that happened and the full audit trail. Now, for option one, where we're verifying against an ID, the user will verify against an official identity object. This could be a passport or a driver's license. This is the one that you create in the wallet initially. This is best for simple identity gating. So if it's about age, nationality, or residence, you can't allow somebody from a certain country to enter your website, for example. There will be no payment involved from the user. And this will either work with the full wallet app or even with the standalone Concordium ID app. The user doesn't need an on-chain account, which is quite important because there is less friction when the user first does the onboarding process. And the advantage is maximum flexibility. So the user will just get a lightweight app, won't have to actually get any CCDs or to get any protocol level tokens, any stable coins on their account. Now, the trade-off here is that if later you want to introduce a payment, the user will need to verify again against the wallet, so it won't just be one step. General use cases for this would be age-gated content, as I've mentioned, gaming, social media, adult content, or geo-restricted services. Option two, we have verification against an account. So this will actually verify that a user controls a Concordium account. In order to have an account, you still need to do an identity check anyways. So this implicitly will prove a verified identity. So this is basically one step above just verification against an identity. It's best for any flow that will involve an actual payment or an on-chain transaction alongside identity verification. So if you're providing a service or a product that is going to be paid, this would be best. All right. The advantage will be that this is only all-in-one. So you will have identity attributes plus payment capability in a single interaction. The trade-off is that the user needs to get a full wallet once with an on-chain account. Use cases would be e-commerce, gambling, financial services, PLT transactions, basically anything that would require an actual payment. Now, this will be the last bit of my part. So let's talk a bit about the verifier service and wallet connect. I've mentioned this before. So the verifier service is an open source middleware. You can find it on the Concordium.com, on the Concordium GitHub. So if you go to github.com/Concordium, you'll find it there. It's an open source middleware between the merchant's backend and zero knowledge proofs operations. So if you're building an app, this is basically everything that you have to use. You don't have to actually design the functions that will call the chain. You will just call one function called create with some simple parameters, and it will create all of the anchors that I've mentioned before, validate all of the proofs, and anchor everything. So the main reason for this is that if you're just building a store, for example, you don't need to know all of the cryptography behind in order to actually use it. You will just have a simple API layer on top, and this will actually call the chain and do all of the complicated bits in the background. What you will get is just a simple verified or failed answer from the API. So you won't actually have to do any cryptography yourself. This is configured through a Docker container. It can be self-hosted easily, and it's fully open source. It will require a private key file because in order to actually put the anchors on chain, you need to do a transaction. So you need an account that will pay for the transaction costs. And the gRPC connection to a node. A suggestion would be that in production to use a managed key service, so AWS, Azure, anything like that, so that the raw key will never touch the actual application memory. This would be in order to be fully safe. Now, on the other side, we have Wallet Connect or Brion. This is the industry standard in Web3 for connecting web apps to mobile wallets. It solves a core UX problem. So how does a website on laptop communicate with a wallet on a phone? This can be easily done on desktop through displaying a QR code. So all the user has to do is just scan it and then the app will open. And an encrypted session will be established. On mobile is just a deep link. So you just click on a link and it will guide you directly to the app. The sessions persist up to 30 days. So this is quite useful, I would say. A user will just have to join once, and then they won't need to rescan. The session will still be open. And all you have to do in order to use it is to register on a Wallet Connect Cloud and to get a project ID. Now, this has been my part of the workshop. So I wanted to build an overview. And from here on, my colleague Doris from the blockchain engineering department will continue. Thanks, everyone.
Yeah, thanks, Dragos, for the first part. Let's see if I can take it over the screen. Okay, I hope you can see it.
Yes, we can see
cool.
it.
Okay, like the second part will be mainly about like showing you some demos and also like real world, how our wallets look like and how the Verify works a little bit in the Block Explorer. So can you see the browser wallet? Yeah, so like first of all, I want to show you a little bit how the wallets work, because we have talked about like full wallets and wallets that only hold identities. So this is a browser wallet, for example, it holds both, like it can hold identities and accounts. What it means, like your identity is something like your passport, for example. That's the first thing that you will create in the wallet. And then in a second step, you can create an account on chain, and this is linked then to the identities. So these type of wallets in Concordium that have like both types of credentials can create these type CK proofs, either identity credentials or account credential proofs. But some of our kind of wallets, they only have identities in there. So later I will show you an ID app that will have only these identities in there. And they will generate these proofs about your passports, but not it's not linked to any on-chain account. So if you need any on-chain account activity and want to prove something about that, then you have to have these account proofs and need to have a wallet that supports that. Okay, so let's go to the slides. So we have talked about that we have built a full kind of dApp, which has like a front end. It has also a backend. The backend consists of this verifier, and the verifier has like two endpoints. And what does the verifier do? It before you ask the wallet to generate a CK proof, you want to first have like a request, and you send a request to the backend and say, okay, I want to generate a request to the wallet, and it anchors this request on chain. So you have an audit trail. So this is one endpoint that the verifier has. And then there's a second endpoint after the wallet has generated a CK proof. And of course, the front end will need to know, is this CK proof actually like valid? Is it like a true in some sense? So there's a second endpoint in this verifier, and you can call it, and it will then verify the CK proof and say, yes, it's valid or not, it's not valid. And it will also kind of anchor the results, or like it will anchor that a verification has happened on chain with a specific transaction. So important to know is like this QR code, it will go to the verifier. So we look into the source code a little bit. And yeah, important to understand for now is like it has these two endpoints, and both of these endpoints send transaction on chain. And because you're probably a developer, we will look a little bit into like what kind of requests or what information you have to send to these endpoints that the verifier works as expected. Okay, so this link will go to our MISC repo. So in the MISC repo, we have the credential verifier service. And here, what I would recommend you to do is, of course, reading the READMEs at the beginning, and then also looking in the docs. So in the docs, we have the API documentation, and there's the two kind of folders for both of these endpoints. As I said, we have a create verification request endpoint and a verify endpoint. And they're done like this one's done at the beginning, and then in the middle is the CK proof generated by the wallet, and then in the end, you call the verify endpoint. So for this talk, we will look only in the create verification request because it's an example that I can show you, but the API documentation for the verify endpoint is very similar. So if you go into one of these API endpoint documentation, you can go to examples. And here you find an example what you have to send to the endpoint for the backend to work correctly. So this is the data you have to send to the endpoint. It might look a little bit complicated, but we will try to break it down. So this here, I would say you can just keep as it is. It's like a dummy data in there, but if you want to use it in production, I would recommend you to use here is a connection ID. We usually put in the wallet connect session. As for source ID, we usually put in the kind of website URL, so like www.google.com. Context string can be your company name. And the public info here, it's just, it can be anything. It's really like up to the merchant what he wants to put in there. And you can just keep it empty, like it's just an empty object if you want to make it very simple. Now, the interesting part is here the request claims. So about this part, you want to talk a little bit more. So what are the request claims? So first of all, this identity, the type stays the same, like we don't have any other type for now. Then what is the source here? So source, as I explained you, we have two types of credentials in some of the wallets. We have identities, and they're like some similar to your passports, for example, information. And the accounts are like on-chain accounts, but they're linked to an identity behind it. So in the end, every CK proof is still done was done on the identities, but in one case, if you go through the accounts, then we have like a link to the on-chain account in addition. And what we specify here is that what kind of CK proof we want to have. So in this example, we say, okay, we want to either have an identity credential proof or an account credential proof. So it means like we accept any wallet that generates a CK proof, either about the identities or about the accounts. We will kind of accept both of them. If you, for whatever reason, for example, what Dragos said, you want to have on-chain payment afterwards, you might want to only use account credentials. And then in that case, you would remove this one and say, okay, I want to actually have an account credential. And the proof should be done about an on-chain account that I know that the account on-chain that's transacting is actually like verified. Then we have the issues here. So what are the issues? So if you generate a new identity in a wallet, so I go through it. So if I create a new identity here, I can select the identity providers. So these are companies. And the first one, like that's the 01, that's the 0 here, that's the 1, that's the 2, and the 3. And because we're on testnet, we have like the fake identity provider. So the first one is the fake identity provider. That means it's a one run by us. So I can show you this. If I go on this one, I can generate any identity on testnet that I want to be. So I just fill in my passport information here. And this allows you to test. Okay, I'll go back. Like it allows you to test different things on testnet without having to use your passport, because of course we don't always have passports of every country or something like that. Okay. And the other identity providers, these are real identity providers. It means they are behind usually, for example, big banking systems as well. So if you open a bank account and in your typical online banking, then you will find these kind of KYC providers as well. And we use them as well in the wallets, and you will find them on mainnet and on testnet. So you can also on testnet test the flow, but of course, usually people use these real identity providers only on mainnet, where the testnet provider is not available. So there's the issuer field here. So what it means that we here allow all issuers that are from the top 3 we're allowing. And usually, if you can kind of extend it, and then you would allow all of the identity providers. And then we have the statements. So there I go maybe back to the slides. So we have 4 different types of CK statements that we can create. So here's an example of a very basic one, the attribute and range statement. What it means is something like you prove that your secret value is between like an upper and a lower bound. So there's a upper, and that's upper, and it's a lower bound. And the very common way you do this is like on date of birth. So that means date of birth. You want to prove that you're, for example, older than 18 years old. It means that you choose a date here. And like you prove that your date is like when you were born is between the lower and the upper bound, and it can kind of translate to that you know that the person is over than 18 years older. I can show you a little bit if you go down of the documentation, that like for all of these attribute fields, like these are the attribute fields that you find usually in your passport or in your kind of like identity document. We have kind of a translated what they mean. So for example, date of birth is abbreviated as DOB. And for each of these attribute tags, we also show which kind of like format it should be provided. So for example, we have talked about the date of birth. Date of birth should be provided in years, month, date. So that's when you know this format, you can probably read and understand that this means like 1st of January 1900. So this is the translation, what it means. Okay, let's go there. And then there's maybe also interesting thing is we also have company identities. So like it's not just human beings that we can identify on chain, but we can also, like as a company, you can register and create a company ID. And then you have, of course, other attribute fields. So for example, the lay code is very important for companies. Okay, now we have seen that how you generate a statement. So we have looked at this first statement. It's a attribute and range statement, and we have used date of birth as an example. But of course, there are more than just one statement. So I can show you that there are more statements you can create. So for example, you can combine them and say, like, okay, I want to prove that you're older than 18 years old, but also that you're part of the European Union. So what it means is like you can just extend the statements and add as many as you want. There's some restrictions, but yeah, you can have like kind of glue them together as you want it. So if you want to have several information about the user, you can ask them, for example, reveal your date of birth, reveal from which country you're from, reveal that you're not sanctioned by someone. And then that's why you have here an array of these different statements. Okay, so for what type of statements we have, like 4 types, I already said it, like we have the attribute and range statement, we have the attribute and set. That's a little bit to think about it. If you want to prove that you're part of the European Union, then you would say you build your set. It's all the countries that are part of the European Union. That's your set. And then you prove that your country is part of that set. So it means like your country that you're from is in the set. It's an attribute and set kind of statement. Then you have an attribute not in set statement. It's usually done, for example, if you have a sanctioned country. So if you know that you're, for example, not allowed to sell your product to a country that you're not friend with, then you can use these attribute not in set statements. And then we have another one. It's called reveal attribute statement. And this one is a little bit different to the other ones. I would say it actually discloses the data. So it reveals that specific attribute field in your passport, for example. So you, for example, can reveal your second name, or for example, often people, or when it's a company identity, maybe people want to reveal their lay number because the lay number is like the number you can, and then look it up the company and identify it. Okay, that's how the backend works, that you have these kind of statements and requests that you can send to the backend. And I hope you have an idea where to look for examples and how to send data to that backend. Now we come to the full kind of depth that I want to show you. There's actually a verify and access tutorial that we have, and I think that would be probably the best for you to start with. I show you that's our developer. Yeah, there's this one. So that's our developer documentation. So I go to the start again. And where you find this tutorial is like if you go to tutorials, there's this verify and access at the bottom. And I really recommend to start here, like just go through the tutorial, do it step by step. And most of the steps we have, you can actually just download the examples from a repo and like run it or look at it. You don't need to code that much yourself. And it really helps to understand the different components that we have. Yep. And what this tutorial does, it builds like this full dApp with the whole verify and access flow. It has this front end, we'll show you in a bit, and it also has the backend. The backend is run as a Docker. So the verify service is run as a backend. It's run from a Docker container, so you can just start it up with Docker. We use a specific SDK It's Concordium verification web URI that you can use, and it helps you to create this wallet connect QR codes and then connect into different wallets that we have. And in terms of stack, we use like Next.js, TypeScript, Docker, and we use it on Concordium testnet for testing, obviously, because there we can generate whatever you want in terms of identities, and you also don't have to pay for transaction fees. Okay, I will show you the whole flow of the dApp for now, and then we go through a few details in the dApp. Okay, this is the dApp that we will build in this tutorial. It's a front end, and it has like news, so similar. So it's like a news website, and the idea is that you only want to show the news to a person if they have proven that they're over 18 years old. So maybe you want to not show like children, like some of the news that you have seen in the world, but it can be in general also like adult content. Maybe you don't want to provide somebody like access to buying liquor or like something. So this website, for now, you cannot see any news because we are not verified yet. So we are not allowed to see the news. You also see we are not verified here yet. So the idea is now that I will click on verify that I'm 18 years old. And then a QR code, like the Wallet Connect QR code, will pop up. And I will, this is a mobile phone that I will show you that's connected. And I will scan with the QR code, with the QR code scanner, the QR code, and will connect my wallet. And at that point, what happens is like then we call the backend, the create verification request backend, this endpoint, and it will generate this anchor transaction on chain. It will generate this request that the wallet needs to have to create a zero knowledge proof. So that's the first step, and the wallet will then react and say, okay, now this is the ZK proof I want to verify. Are you really want to verify that? And as a user, you can always say like, yes, I approve. I want to verify that or want to generate such a proof. So once the user has approved it and generates such a proof, it's sent back to the front end, and then from the front end, it's sent to the verifier backend to this endpoint, the verifier. So this is a little bit the flow. We do this once, and I try to stop a bit when it gets too fast, because actually very fast. That's maybe also the interesting thing. So I click on older than 18 years old, so like the QR code is generated. It's Wallet Connect QR code. So I need to, here's my Concordium ID app. So I open my Concordium ID app. Of course, I need to log myself in. So then you can say scan QR code. So I connect my wallet, and now the backend already has the first anchor transaction sent. And it takes 2 seconds until the anchor is on chain, and now the wallet already pops up and asks the user, do you want to approve that? Do you want to generate the ZK proof of about your identity? Because you will reveal information, you will reveal that you're over 18 years old. So you can, as a user, you can scroll down and see what you're actually revealing. So in this case, we are revealing that we are older than 18 years old. And that's a statement that you have seen before. We're doing an attribute and range statement about your date of birth. And this is the lower and upper bound that we're trying to prove. And as a user, you will then click approve. The ZK proof is generated, sent to the backend. The backend sends it to the verifier endpoint. The verifier verifies that it's valid. And then another anchor transaction is sent on chain. And you see the news are kind of visible now because we are verified now. You see that we are 18 years old, we have been verified, and we're allowed to see these kind of news. So this was the whole flow. I hope you have seen how fast it is, and yeah, that everything works smoothly. And let's continue. There's a few things in addition I can show you. First of all, like I think just to remind you that the backend, it had like 2 endpoints. So we talk a little bit about the backend interactions. So we had like one interaction with the backend, which was during creating the verification request. And we had another endpoint that we were calling, which is this verify endpoint, to verify that the ZK proof is actually valid. And both of these endpoints in the verify service will create an anchor transaction. So there's a special type of transaction. It's called a data register transaction we write on chain. And to distinguish them, we have this abbreviation. So this means verifiable request anchor, and this means verifiable audit anchor, but it's just names that we gave these type of transactions. And also I want to show you how these transactions look on chain, because it might be confused what is it or like how it looks like. So here there's some links to like such a transaction. You can actually look at the account. So this is the account that is behind the verifier backend at the moment. and if we refresh it, we will probably see that this was the 2 transaction I just sent while doing the demo. So we can look at the first transaction. This is the request anchor, and I think the best thing is to look here. That's the data that's written on chain. And yeah, we have the type, as I said, we call them VRA. And the only thing that's written on chain is a hash. And the hash is kind of done, the whole request of the CK statement that you want to send is put in there, and also like a random nonce. So this hash looks really completely random to anyone. So there's no way you can figure out there's no data written on chain that sense that can be identified. It's really like a random hash string. But we do this kind of anchoring because it allows us to prove that the request and the flow was done like freshly, and people cannot reuse an old CK proof and kind of replay an old CK proof. So that's really the reasons why we do these anchors. And then we can look also in the second anchor. So this was the second anchor that was sent when we verified the proof. And it looks very the same thing. It's really again a random hash. But here's it's a favorable audit anchor now that was written on chain. And the data type of the transaction, we call them data registered transaction. Okay, let's continue. I have a few more information, maybe how that helps you hopefully to get started with the tutorial or with in general such a setup. So for the front end, we have this great Next.js app. So what we use there is like TypeScript, Tailwind, app router, and in the tutorial. So if you're familiar with this, I think it will be quite easy for you to start. Another thing that you can look into it is like this npm package that we have, because it helps you to generate the QR codes for Wallet Connect, and you don't have to think about or like implement any of them or like any dependency, because they're all kind of bundled in this nice package. It also helps you to interact with the verifier, and it makes it much easier. Then we also have this local file. When you run it, there's some kind of data you have to add, but there's some default data already in there, which allows you to connect to the testnet network. So you might not need to change anything, or not as much. Like one important thing is probably that you have to change the Wallet Connect project ID, because you have to use your own wallet project ID and generate it on Wallet Connect on their cloud. This you roughly have to do, or like look into it when you start the front end. If you want to start the verifier backend, what you have to do is like you get this Docker image that we have provided. It's like the one that I showed you here. That's the source code from this. What you have to do when you get the Docker image, one thing you have to do, you need a private key, because there's an account at the backend that sends these anchor transactions. So we'll need to get a private key from one of your wallets. So there's a lot of our wallets, there's ways to export the private keys. So go to account, and then you can export your private key, for example, here. So the backend needs access to a private key, and that's what you have to add. Of course, what the verifier also needs, it needs to have endpoint to a node. So you need to have a testnet node connected to it. But we also have public endpoints for that, so you can use them. And then the rest you have to do is like just like Docker compose up, and then you will have the verifier running, and you can check that it's running correctly, for example, checking the health endpoint. Yeah, exactly. One thing maybe to notice, like I would say the only thing you actually have to do if you just want to get started is like getting a Wallet Connect project ID that's on the cloud. That's probably the only thing that's, yeah, it takes a little bit of time, but otherwise the other things should be straightforward if you're a bit familiar with programming. Then there's another slide more about a few like kind of hiccups or troubleshooting that might help you and if you do it for the first time. So to test that everything is working, you could, when you have started your front end, when you have to start your front end, the thing you can test is like look at the localhost 3000. I think it's the default port. If you see the front end and everything works as correctly. The next thing you could test is like click on the verify age button. If you see a QR code popping up, then you know that the Wallet Connect kind of flow works, or at least that the initialization works of it correctly. And the next thing is then, of course, like checking that the wallet can generate these CK proofs, and you're able to approve them in the wallet and get access to the news feeds on the website. So this is kind of the testing flow you would do, like to make sure everything works as expected. And in case of any of these steps there's some hiccups, then I would recommend you to look through the following things. So if the QR code is not shown, then likely something is wrong with the Wallet Connect project ID. Maybe you have not generated it, or you have to look into like if the kind of npm package that you have installed from Concordium, this is something not working correctly. If the verification fails for some reason, then you can look into the logs of the Concordium file. Maybe there's some information what is missing. Maybe the private key is missing that you cannot send the anchor transaction on chain, or something in the verification has failed. And if there's something problem with the sessions that they're persisting, as if they get some errors around it, then maybe it helps to like clear the Wallet Connect connection in your wallet. There's some different areas where you can delete it as a button, because often when you do a lot of debugging and restarting, then maybe something has not cleaned up correctly because you have kind of cut in the middle of the flow of somewhere. And of course, if you run this whole flow, and then the next step, what you probably would like to do is like extend the statements for your use case, because the tutorial is about like proving that you're older than 18 years old. But for your use case, you might want to prove something else. You want to maybe prove that your EU residency is that you're EU residents. And yeah, you can choose when you can play around with these different attributes and statements what you want to prove. Okay, let's have a recap. For this talk, we had a lot of different information, especially from, I think Dragos gave a really good overview of the technical details that we have. So we tried to communicate what the technical difficulties is, why we need compliance and privacy, why both of it is important, and why we think that the solution we built kind of satisfy both people, so auditors can check and audit the flow and see that actually verification has been done correctly and people have only been let into the website that were supposed to be let in. But on the other hand, we also have make sure that the user's privacy is kind of taken care of, that people don't reveal information they don't have to reveal. The Verify and Access framework that we have on Concordium is privacy preserving, but it's at the same time also audible and compliant. So this is kind of the combination of both of these things. We have two verification methods. The important thing is that like one is about the ID, and one is about an addition, I would say, about an account on chain. So the account on chain is usually then used when you actually want to have in addition some kind of payments and want to be sure that the account it's paying on chain is actually verified, for example, over than 18 years old or not from a specific country. There are three verification records. The last and the first one, they are the anchor transaction that is sent on chain, and then we have in the middle this verification audit record, which is a data record that's stored in the database and the merchant database. And it's usually kept there for the merchant to be able to prove to kind of an auditor that the verification has been done correctly. Our services or our components, they're all like open source. They're self-hosted. You can easily kind of play around with them and kind of adapt them to your needs. The proof request can be quite easily extendable. So we have these four different types of proofs: range proofs, set membership, non-membership proofs, and reveal kind of attribute statements. And you can kind of plug them in and combine them in a way that it makes sense for your use case. On every verification that we have, it's like is a kind of anchored on chain that gives like this audit trail. And also important, for example, it's a personal identifiable information. It's never written on chain. It's really just a hash, and in this hash is also random nonce in there. So it's really like a totally random hash that's on chain. Like no one can get any information out of this hash. There's no way to kind of link it back to the original proof data that you, for example, have given to the merchant. Okay, here we have some more information. I think depending on where you want to start, if you want to more read about the documentation, or want to read up the tutorial, or want to look in the Proof Explorer, then it's a good start probably here. Yep, we also have like a Proof Explorer. I can show you this as well. So this is our Proof Explorer. We just use it for internally, but you can also kind of access it. It's like open to everyone. And we use it usually just to test our CK proof. So it's not like a nice font. It's not meant for anything to kind of show to people, but we, for example, generate proofs usually here and then test that our wallets are working correctly. And you can use the ID up here as well and then just see how these proofs are generated. I'm not sure if it's connected with this one. Oh, this is something else open. Just here's the proof. So then the wallets pop up. That's like the browser wallet now, and then you can also prove for similar things that you're older than 18 years old. And we use this proof explorer just to play around with our proofs and kind of combine them. Yeah, any questions? There's like one question, where's Concordium did defined? Is there any public resolve form? We have a document that defines the dits.
I've sent it right after that, Doris.
Okay, sure.
Sweet. I don't know if there are any other questions from you guys. Then yeah, do feel free to drop them in the Discord, and Dragos and Doris can answer them, or I can let them know at least. But thank you guys very much for that webinar.
Sorry, Gerald, one quick mention at the end.
Yeah.
So during our workshop, the Concordium town hall happened. So if you want to know about where Concordium is heading next, you can rewatch it on X or LinkedIn on the official Concordium account.
Awesome. Cool. Yeah, anyway, thank you guys very much for that. That means we are now 3 sessions deep into this, so we've got 5 more to go. That makes us about a quarter of the way through this series. And again, same time next week, on the 7th of April, we're going to be learning about protocol level tokens, again with Dragos and Doris. So come back for that to make sure that you guys get your certificates. If you have any webinars which you can't join for whatever reason, then just shoot me a message on DMs on Discord or send me an email, and then make sure you catch up on recordings, and I'm sure it'll be all okay. And then hopefully you'll get your certification. You'll graduate from this series, post it about LinkedIn and add it to your CV, and all should be good. And the recordings from today's webinar will be up on the platform probably by tomorrow. And if you guys would like the slides, I'm sure Dragos can share them with me, and I can add them onto the Discord if needs be. And yeah, as always, any questions, drop them in the Discord or send me an email. And yeah, thank you very much, Dragos and Doris, today. And we'll see you all guys next week.
Thank you. Have a good evening.
Thank you.
Bye-bye.
Thanks for joining.